Okay, now number 4. Suppose we have integral equals the limit from 0 to pi over 2. And suppose here we have cosine x, and here's the x, and let's say we have 1 plus sine squared x. So the format here actually is tan, because we're having 1 plus something squared, which is 1 plus u squared, which is 1 plus tan squared theta in general. See, the formats are the same. Therefore, we can say sine of x equals tan of theta, for example, but we're not gonna do that one, just to avoid the confusion for the students, and we're gonna say let u equals sine x. Therefore du is just gonna be cosine x dx. And then for the limit, the lower limit, sine of x is 0, which is sine of 0 is 0. And in this case, equals u, lower limit, I would say u L for lower limit, and sine pi over 2, which is 1, is the u upper limit. Therefore, we're going to have the lower limit is 0 for u, and the upper limit is 1. And now cosine x dx is just du from here. And the square root is 1 plus u squared. And now another time, we're gonna say u equals tan theta. Therefore, du is gonna equal secant square theta d theta. And now for theta, what do we get? Tan theta being 0 yields theta being 0. And tan theta being 1, this gives us theta being pi over 4, because tan of pi over 4 is just going to be 1. Tan pi over 4 is 1. Therefore, we're going to have 0, and then pi over 4. And now we're going to have du, which is secant squared theta d theta divided by square root of 1 plus tan squared theta. So we're going to have integral of 0 to pi over 4, and then upstairs we're having secant square. This is secant square theta d theta, and 1 plus tan squared theta under the square root is again secant theta. So we can cancel the square with the theta itself. Okay, and we're going to get secant and we're gonna get integral of 0 to pi over 4 secant theta d theta. And this one is nothing but ln of secant theta plus tan theta from 0 to pi over 4. Therefore, we're gonna have ln of secant pi over 4 plus tan pi over 4 minus ln of secant 0 minus tan 0. So cosine pi over 4 is 1 over root 2, and the reciprocal of 1 over root 2 is square root 2 plus 1 minus ln of 1 minus tan of 0 is 0. And we know that ln of 1 or log of 1 in general is 0. Therefore, we're going to have ln of square 2 plus 1, and we're done with this integral.